So the subject of this workshop is on factoring quadratics, and this is part one of the workshop. So all of the quadratics we're going to work with right now are going to have a single 1x squared. So we're taking quadratics that are in standard form, which would be ax squared plus bx plus c. But for now, all of the cases we're going to deal with are going to have a is 1, which is just not written, right? So when we say we're going to factor a quadratic, we mean we're going to convert it into factored form. Or if you think about how you factor a number, so if I say factor 36, what are the factors of 36? Then it's things that multiply to make 36. So we'd have 1 and 36, or 2 and 18, 3 and 12, 6 and 6, right? So we're finding things that multiply to make 36. We do the same thing if we're factoring a trinomial here. So we're going to find two binomials, right, that are going to multiply to create x squared plus 5x plus 36. And the way you do this almost seems like magic, at least in this case. We're going to find two numbers that multiply to 6 and add to 5. Why 6 and 5? Because here's where we get the 6, and then this is where we get the 5. And actually, the sign is important here. So it's a positive 5 and a positive 6, right? So what are two numbers that multiply to 6? Well, it helps if we list out anything that multiplies to 6. So we have 1 times 6 is 6, but 1 plus 6 equals 7. That doesn't work. 2 times 3 is 6. 2 plus 3 is 5. So we found one that works. Could list out all of them, but, why bother? We found one that works. So this means that this is going to factor into x plus 2 and x plus 3. And it's that simple. And if you don't believe me, we can multiply this back out. X times x, x squared, x times 3 plus 3x, 2 times x plus 2x, and 2 times 3 plus 6, combine like terms. And we're back where we started. So it works. It seems simple, but it can get a little bit more complicated when we throw negatives into the mix. So let's do one with negatives. So what about x squared minus 10x plus 21. All right, so same thing. We need to find two numbers whose product is positive 21 and sum is negative 10. Now, if you think about this analytically for a second, we're going to multiply to a positive and add to a negative. That means we're going to have two negatives. So what are factors of 21? Well, we have, because if two negatives multiply to a positive, so negative 1 times negative 21 equals 21, but negative 1 plus negative 21 equals negative 22. So that doesn't work. 3 times 7 is 21, so negative 3 times negative 7, negative 21. Negative 3 plus negative 7 is negative 10. And there's our factor pair. So our factors are going to be x minus 3, x minus 7. Now connecting this back to quadratic functions, that means if we were saying this was a function, f of x, then it's going to have roots. x equals 3 and x equals 7, right? Switch the sign, find out what makes it 0. So 3 minus 3 would be 0. 0 times anything is 0. Same thing with 7. Let's keep going. Now let's do one that has a negative as the last term. So x squared plus 7x and minus 30. Okay, so we need to find two numbers. Product is negative 30, and sum is positive 7, right? So if they multiply to a negative, that means we need to have one negative and one positive. And notice they're adding to a positive, so that means that our positive is going to be bigger than our negative. So we can start by listing factors of 30. So we have 1 and 30. But we need it to be negative. And remember how I said if it's going to add to a positive, that means that we're going to make the bigger one positive, because that's always going to add to a positive. So it'll be negative 1 and positive 30. And that's negative 30. But negative 1 plus 30 is 29. So that doesn't work. We could have 15 and 2. So negative 2 times 15, that's 30. Negative 30, but negative 2 plus 15 is 13. So no, neither of these worked. We can have 3 and 10. Negative 3 times positive 10, that's negative 30. And negative 3 plus 10 is positive 7. And we found our pair. So this is going to factor into, we have x minus 3 and x plus 10, right? I'm going to do one more example that's a little bit trickier. It's not going to have a coefficient of 1 as the x squared, but we're going to manipulate it so that it does. So let's do 2x squared plus 4x plus 2. Now, it does not have a coefficient of 1. But what do you notice about these three numbers? Is that these are all factors of 2. So if you have something where you can divide the same number by everything, then you can factor out that number. So what I mean by factor out is it's like we distribute in reverse, which is all factoring is, really. So we're going to put a 2 out front, and now we have x squared plus 2x plus 1. Because it's like I took a 2 out of everything. If I were to distribute this 2 back in, I would have 2x squared plus 4x plus 2. So I pull the 2 out, and now I have that 1x squared that I want. And I need to find two numbers that have a product of 1 and sum of 2. And this is an easy one. 1 times 1 is 1. 1 plus 1 is 2. So we're only factoring this inside. So the 2 stays out front. And we have on the inside x plus 1 times x plus 1. Another way to write x plus 1 times x plus 1 is 2 times x plus 1 squared. Okay, so the deal with factoring is it just takes a lot of repetition to get the hang of, and it really takes an understanding of your times tables. So the quicker you are with multiplying numbers in your head and knowing your multiplication facts, then the better you're going to be at factoring. At this point, I do kind of want to show you how that method of the finding the product, finding the numbers that have the product of your last term and the sum of your middle term works. So let's just say that we have two binomials. So let's say x plus a and x plus b, right? If we multiply these two together, we would get x squared plus plus bx plus ax, and then plus ab, right? And then if we, so bx plus ax, you might not quite see how to combine those, but altogether we have a total of b plus ax, or a plus bx, right? So a plus b x plus ab. Right? Now this is the most general case because we used only variables. And you see here the last one is a times b. So, and the middle one is a plus b. So in fact, if you were factoring anything, it would make sense that you would find two numbers, a and b, that multiply to create your last term and then add to create your middle term. And this works the same if if one of them's negative, it's still gonna multiply to the last one and add to the middle one. All right, so that's going to conclude this part 1 of factoring quadratics. There will be many more parts to come.